In this video, we'll cover the problem, find first and last position of element in sorted array. So here, we're given a sorted array and a target number, so in this example 8. We want to return two values. The first one is the index of the first occurrence of the target number in our sorted array. So this index would be that value. The second thing we should return is the index of the last occurrence of this target number in the array. So that would be this index. If the target is not found in the array, we're going to return -1, -1, and we must write an algorithm that works in log n runtime complexity. So this question is clearly stating to us that it's binary search. The way we know this is that the array is sorted, and they're telling us that we want log n runtime. That almost always means binary search. In practice, in an interview, you're probably not going to be told that this is log n, or you should solve it with log n runtime. But finding numbers in sorted arrays or finding elements in sorted arrays typically lends itself to binary search. The sorted part is key. This problem is also great because it shows templates and patterns that are very common for binary search, and it's just generally very good practice. If you can solve this problem effectively, it generalizes well to other binary search problems. It also at least used to be a very common Facebook problem. I don't know if it still is. Yeah, it looks like it still is. So it's definitely a good problem to be doing. Okay, so the way we're going to do this is we're going to write two binary searches. The first binary search is going to find the first occurrence of an 8, in this example, obviously. And the second binary search is going to find the last occurrence of an 8. So I'll switch this to ES6 arrow function syntax real quick. And then I want to talk about an example before we code any of this. So we'll kind of do this piece by piece. So for now, let's focus on finding the first occurrence of an 8. So what I'm going to do is I'm going to apply a filter of num greater than or equal to 8. So for each number, if it is greater than or equal to 8, we're going to say true, otherwise we'll say false. So we would do something like this here. Now with our filter, clearly this becomes find the first true, find the left boundary of trues. And we know how to do that with the templates we've constructed. So what we're going to do here is we're going to say first occurrence index is going to be find first occurrence, and we'll pass in nums and the target here. And now we'll write this function. So we'll find the first occurrence, we'll take in nums and target, or maybe get first occurrence index. Get first occurrence index. Either is fine. We'll just stick with this since we've already done it. Okay, so we're going to start our left index at 0. And our right index is going to start at the last index. I'm going to store a constant for the last index, just so it reads a little bit cleaner, or more like English. So we'll do last index is nums.length -1. We're also going to have a variable for our first occurrence. So we'll say first occurrence index is going to be, and we want to have some default value. So we're going to use -1 in this case. So if we don't find our index, we want it to return -1. So I will create a constant, we'll do it at the top, called not found, which will be -1. Or we can say target not found, maybe. Okay, so we'll default it to this, so if we never overwrite it, we're going to return this in the end. Now, we'll say so long as the left index is less than or equal to the right index, we continue on. Our mid index is going to be get mid index with the left index and the right index. Now we can write this function. So it'll take in the left index and the right index. And what we're going to do is we're going to say find the difference between the left and right index, cut that in half, and then add that to our left index. And that's a way that we can get the midpoint between these two values, and it doesn't require us to store a massive number, even in the case that left and right are quite large numbers. Okay, so now we have our mid index. Now what do we want to do? We want to use our filter here. So we're going to say, we'll grab our mid num. So we'll say nums at mid index. Here we're going to say if the mid num is greater than or equal to our target. That's just grabbing this filter from right here. That gives us this array. Now we know the way this works with the template. If we have a true value, we're going to say, all right, update our index, and then search to the left. So we'll say, since this is true, we'll say boom. The first occurrence index equals the mid index, and then we're going to search to the left. So we're going to say right index equals mid index -1. Otherwise, we'll just say we need to find a true, so we're going to move to the right. So we'll say left index is going to be mid index plus 1. In the end, we can come here and we can return our first occurrence index, and we should be good to go. If the target does exist in the array, we're going to find the earliest occurrence and return that. Otherwise, we're going to return target not found. So we have our first occurrence index here. Next, we're going to get our last occurrence index. And I'm going to write a function find last occurrence, noms, and target. And it's going to be a very similar function here. Okay, so this is going to take in nums and target. And last index is going to be nums.length minus 1. This is going to look really, really similar to the function above. I am going to write it in a way that does duplicate a lot of code for now. So just don't worry about that for a second. And we'll talk about why I'm doing that afterwards. So quickly, let's look at an example. So I'll just write here, this is finding the first occurrence. But what if we're finding the last occurrence? So we have the same array. Now we can look at the other direction. So we want all these guys to have one value and then this to be a different value, so that we can find the kind of like the boundary that's all the way on the right side. So we can just do less than or equal to 8. So we'll do a filter for num less than or equal to 8. So then we're going to get true, 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 false. So we can do our similar template that we've seen many times and just keep moving until we find the rightmost occurrence of a true. Okay. So we'll come here, we'll say left index is going to be 0, right index is going to be last index, and our last occurrence index is going to be target not found. Then we'll say so long as the left index is less than or equal to the right index, we're going to do some work. We're going to grab our mid index. Now we've already written the function, so we don't have to write it. We'll grab our mid num, which is going to be nums at mid index. Now here we want to apply our filter. So we want to say if the number is less than or equal to the target. So if min num is less than or equal to target, what does that mean? Well, it means this is a candidate for the last occurrence. So we're going to override our variable to be the mid index. Then we're also going to say search everything to the right. So for here, we search everything to the right. So we move our left index across ourselves. So left index is going to be mid index plus 1. And there's the else case, which is that we are greater than the target. So then we want to search everything to the left. So we're going to move our right index across ourselves. So we'll say right index equals mid index minus 1. In the end, once we're done with that binary search, we're going to return our last occurrence index. Now we can come down to our bottom function. We do need to actually make sure that these are valid indices before we just return our answer. So here's what we'll say. First of all, the first occurrence index should be less than or equal to the last occurrence index, because sometimes they could potentially cross. Then also, they should both not be equal to target not found, because if they are target not found, we're supposed to be returning -1, -1. So here I'm just handling valid input. So we'll do last occurrence index not equal to target not found. If all of these things are true, the first index is less than or equal to the last index, and then both of them are not equivalent to target not found, then we can return the first occurrence index followed by the last occurrence index. Otherwise, we want to return -1, -1. We have our nice constant for that, so we can do something like this. Okay, that should work, so we can go ahead and validate. Okay, it works there, and it works here as well. Okay, and just to confirm that this part is required, if we submit without this, we get some errors. So you can see that with the way our boundary logic works, there are still values that we find that are not our answer. It's a good way to describe this. Okay, yeah, consider like 6 here. Imagine we're trying to do find first occurrence. Say we're at 8. We look at 8 is greater than or equal to target. So we're going to set first occurrence to be the value of 8. Then we're going to look in the right half. We're going to grab this 7. We're going to say, is 7 greater than or equal to 6 the target? Yes, it is. So we're going to overwrite first occurrence index to be this 7's index, which is index 1. So this is going to be 1. By similar logic, we're going to get index 0 for the last occurrence, because in the event that the number is not present in the array, we get some weird behavior. So we do actually need this check to make sure that the first is less than or equal to the last. Okay, now the other thing to discuss is code reusability. If you notice here, outside of these if statements, everything is basically exactly the same. I guess other than these variable names here. So this definitely can be done in a way that does not require writing all this duplicated code. We could write some generic function that takes in a Boolean that's like, are we finding the first or last occurrence? And then based on that, it does these updates. And that can be done. It tends to get quite a bit more complicated and messy. For this problem, I really want you to focus on the algorithm, not the kind of like deduplication of like separating this out into one function. You certainly can spend time on that, and we have a solution in the GitHub repo that shows you how to do that. But honestly, in an interview, this is something that most interviewers would be pretty satisfied with. And if you got to this point where you had this done and working, then you could talk about potentially refactoring. It definitely is not the kind of thing where you should try to write it reusably first, because that's probably going to slow you down and confuse you a bit. And it's definitely more important to get a working solution first. All right. Well, that's all for this video, and thank you for watching.